everybody, we're doing polar coordinates. We discussed how to evaluate some integrals using polar coordinates. Are these good? Are polar coordinates good, or should we do more? We do more examples. We do one more example. Let's do one more example. Before we move on to harder examples. Okay, great, guys. Okay, so find the integral of x squared dA, where R is the region inside the first quadrant lying inside x squared plus 1 squared. Whom will it choose for number? 3? 9. So 3 squared is 9. And under the line y is equal to x root 3. So first of all, what do we start? How do we start? We start by, everybody, we start by sketching the region of integration, right? It looks like a disk. This looks like a part of a disk. The entire disk, but it's part of a disk. So let's do that. So the disk in the first quadrant, what is the radius of this disk? 3. Great, so I'm here, I'm in this quadrant, and it's below the line y is equal to x root 3. Okay, so let's draw the line y is equal to x root 3. So if y is equal to x root 3, this is what is the region I'm looking at? This one or this one? 1 or 2? 2. Below the line, y is equal to x root 3. So y is equal to x root 3, and this is the circle, x squared plus y squared is equal to. And I'm looking at this region. I can describe it by what? By polar coordinates, right? R goes from where to where, everyone? 0 to 3. And theta goes from 0 to. So y is equal to x over root 3. What is the angle here? What is the slope of the angle? The tangent of theta is the slope of this line. You agree or not? Yeah? So tangent of theta is root 3. What is theta? And theta is in the first quadrant. What is theta? Theta is pi over 3, right? You agree? Everybody, do we agree? What is the slope of this line? It's root 3. Agree? Now the slope of this line is the tangent of this angle. You agree? The tangent theta is root 3. What is theta? Theta is pi over 3. Okay? Theta is in the first quadrant, so theta is pi over 3. Since theta belongs to 0. Okay? Great. So theta goes from 0 to pi over 3. Yeah. What happens to my x squared? What does it become? My x squared. What is x, everybody? R cosine theta. So my x squared is r squared cos squared theta. And my dA, what does it become in terms of dr d theta? R dr d theta. The Jacobian is r. I have d theta dr. Right, because I'm starting with theta. Great, so let us integrate. It's easy to integrate. I am integrating from 0 to 3. Right, it's the product of two functions, one of r and one of theta, defined over rectangles. Right? You agree? So what can I do? I can split the integrals into two. into a product of two integrals. 0, 5 over 3, sorry. Like I have cos squared theta d theta. So far so good? That's fine? Yeah? It's okay so far? Great. How do I integrate this? R4 over 4. So this is 3 to the 4 over 4, which is 81 over 4. Right? Yeah? And how do I integrate cos squared theta from 0 to pi over 3? What do I use? The half angle, double angle, whatever you want to call it. What do I call this? 1 plus cos 2 theta over 2. So what is 1 plus cos 2 theta over 2? What's an antiderivative of this? Do you want me to write this step? Do you want me to write this? So let's write this here. 1 plus cos 2 theta over 2 theta. This is 81 over 4. So what do I get? Theta over 2, right? Plus sine 2 theta over 4, right? Pi over 3 to 0. So 81 over 4. Pi over 6. Plus sine 2 pi over 3. What's sine 2 pi over 3? It is? What is it? Yeah? What is sine 2 pi over 3? Sine 2 pi over 3? Root 3 over 2, right? That's root 3 over 2, so root 3 over 2. Okay? I hope it's correct. Okay. Great. Now let's move on to examples that are slightly more complicated. So far we have focused a lot on regions or on circles that are centered at the origin, right? Everybody, did we do this? Is it good? Yeah? Did we get this? Yeah? Is the integration correct? Great. So far we have focused a lot on circles that are centered at the origin. But you know, there is nothing that forbids us of considering circles that are not centered at the origin. Of course, it's going to be a bit harder. So let's see how we deal with such situations. And the best thing we can do is find an example, and to do it by an example. Okay. Find the area of the region. This is from the book, so it's inside the circle. X minus 1 squared plus y squared is equal to 1. And outside the circle, x squared plus y squared is equal to 1. Okay. Let us draw this. Yes, sir.
In the previous exercise, how do you get template of it being? Is it y or x?
Yeah.
If you did like cos theta as x over r, would that work?
Cos theta is
X over r.
sure.
Like,
But you have to find the x. Well, you can choose any x, right? So we're gonna find this angle here, right?
Yeah.
Pick a point. Say x equal 1. What is y? Okay.
Yeah.
Pick x equal 1. So what is r here? You can, right?
This is r always 3.
Yeah, I mean, but so for example, you can pick a point. You can pick a point here. What is r? R is the hypotenuse. So if pick x equal 1 and y is equal to root 3, what is r? In that case, square root of 3 plus 1, which is 2. Okay. So you have here 1, root 3, 2.
Okay.
Okay. So what is cos theta? Is 1/2. What is sine theta? Is root 3 over 2. Okay? It doesn't matter. It will scale, whatever number.
Constant R.
The R is not constant. No, the angle is constant, right? Any point you pick here, any point you pick on this line, will lead to the same angle. Okay? Great. Great. Now, what's the first thing we can try to do here? If you have such a problem, what's an easy thing to do? To sketch. Let's sketch this thing. So, the first equation, the second equation is easy. It's a circle of radius 2, right? Of radius 1 centered at the origin. The other one is a circle of radius 1 centered where? Centered at 1, 0. So centered here. This is a bad circle. Okay? Great. This is the circle. X minus 1 squared plus y squared is equal to 1. And this is the circle. X squared plus y squared is equal to 1. Agree or not? Yes? And I'm asked to find the area inside the circle, outside the second circle. So outside the circle and inside this. So I'm asked to find this area. Agree? Everybody, do we agree? Yeah? Now, how do I do that? Looks like a bit complicated. So let us use polar coordinates. Now, x squared plus y squared is equal to 1. How can I describe this circle? How can I describe this circle? X squared plus y squared is equal to 1. What is x? R cos theta. What is y? Is r sin theta. So what is x squared plus y squared? It's equal to r squared. So it's r squared is equal to 1. Everybody agrees. Equivalently, r equal to 1 because r is a positive number, right? So x squared plus y squared in polar coordinates becomes r equal 1. So far so good. Yes? Now, how do I obtain an equation in polar coordinates of the other circle? I can just replace, right? If you replace x by cos theta and y by x by r cos theta and y by r sin theta, I obtain an equation. You agree or not? This equation will be possibly in terms of r and theta. Agree or not? Let's do this and see what happens. So I will expand this one first, just because it's a bit easier. This is this. What happens here is x squared plus y squared minus 2x plus 1, right? Let's write this here. Minus 2x plus 1 is equal to 1. So this is just x squared plus y squared is equal to 2x. Agree or not? Everybody, do we agree? Yes. Yeah? Now what is this? This is r squared is equal to 2r cos theta. Everybody, do we agree? Now I can cancel the r because 0, 0 is not on the circle. You agree? Oh no, this is plus, let's cancel the r because on this part, right? Look at this part. Looking at this part. Is 0, 0 part of the thing I want? No. So I can cancel the r. Okay, do you agree? Because in this region, can xy be 0, 0 on this region? No. Can r be 0 in this region? R is equal to 0. What point does it represent? R is the distance from the origin. If the distance from the origin is 0, what is my only point? 0. So if r is different than 0, if my point doesn't belong to the region of integration, then I can cancel the r. Clearly, right? You see that? Everybody, do you see that? This is the region where you're integrating, you agree? What is the point r equal to 0? It's the origin. Does the origin lie in this region? So r is different than 0. Right? So you can cancel it.
Can you just simplify it?
You can, well, if r is equal to 0, then, right?
Well,
You cannot divide by 0. Okay? So if r is different than 0, then you can cancel it. Okay? So far so good. Great. Well, where does r go? Any questions? It's good here. Where there is minus 2x. X minus 1 squared. X squared minus 2x plus 1. Okay, I just told you what I wanted to do it immediately, but then is that clear? Great. Now I have to describe this region. How do I describe this region? I need two bounds, or I need to describe two coordinates, r and everybody, r and theta. Yes.
Can you describe like 2 cos theta is equal to 1? Because both equal to 1?
Sure. Okay. Step by step. Step by step. Very good. So I need to describe r, and I need to describe theta. R, from where to where does it go? I can say it goes from here to here. Do you agree or not? Yes or no?
Yes.
Now what is the lower bound for r? A point on this circle satisfies what? R is equal to 1. So r will go from 1 to a point on this circle will satisfy what equality? R is equal to 2 cos theta. We agree or not? Any questions on this? Yes or no? Good. Good. We see that? We repeat this again. Once more. R, you agree that R, my set of points varies from here to here, 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 and so on. On this circle, so R varies from this to this. On this circle, what is the value of R? 1. And on this circle, what is the value of R? 2 cos theta. It depends on the angle, you agree? So R will go from 1 to 2 cos theta. Once you describe R between two functions of theta, you need to describe theta between two values, right? Two constants. Everybody, we agree? What are these two constants? How do I find these two constants? Yes, sir? Oh, you do? Oh, yeah? Yeah, okay. So as your friend suggested, I need to find the angle at these points of intersection. You agree if I say that theta varies from this angle to this angle, and r varies from 1 to 2 cos theta, I describe my region? You agree with this? If I tell you, call this angle theta 1 and call this angle here theta 1 and theta 2. Theta 2 is negative, okay? If I tell you that theta varies from theta 1 to theta 2, and r varies from 1 to 2 cos theta, don't I get this region? Now how do I find these two angles? You suggested already, yeah? I equate the equations of the two circles. How do you find the point of intersections of two circles? You equate their equations, right? Here, in terms of r and theta, you also equate their equations. Instead of doing it with Cartesian, you do it with polar. So how do I find this? So r is equal to 1, and r is equal to 2 cos theta. How do I solve this system? 2 cos theta is equal to 1, so r is equal to 1. 2 cos theta is equal to 1. Of course, you have how many solutions? solutions. How many theta satisfy this? Infinitely many. But how many lie in one third of a circle, in a single turn? How many? 2. Let's pick. What's the easiest thing to pick? So I pick theta equal minus pi over 3, and theta is equal to pi over 3. We agree, everybody? So we pick r is equal to 1, theta is equal plus or minus pi over 3. Say theta belongs to, say, minus pi and pi. Well, I don't know, but anyways, it doesn't matter here. Okay? Principal value, it's from minus pi to pi. Minus pi is excluded, right? I don't know. Anyways. Doesn't matter. We agree with this? So this angle corresponds to theta is equal to pi over 3. And this angle corresponds to theta is equal to minus pi over 3. So I integrate from minus pi over 3 to pi over 3. I want the area. What is the function I want to integrate? If I want the area, what function I integrate? 1, right? 1. Now, my dx dy, what does it become? Everybody? My dx dy becomes r dr d theta. Notice, if theta is between minus pi, a good check. If theta is between minus pi over 3 and pi over 3, 2 cos theta is bigger than 1/2. You agree? If theta is between minus pi over 3 and pi over 3, 2 cos theta is bigger than 1/2. So 2 cos theta is bigger than 1. You're safe, right? You see that? The upper bound should always be bigger than the smaller bound. Okay? So far so good? Questions? Questions?
Why is theta belongs to minus pi and pi? No,
I'm just picking theta to be restricted at minus pi to pi, and I look at the solutions here. Okay? Is that clear? Is that clear? Yeah.
Why is it the order theta and not theta to order?
Because I started by r.
We could have switched them.
You could have switched, but it would be a bit more difficult. You have to express theta in terms of r. So how would you express that? So theta in terms of r, theta would be r cos r over 2, right? Does it look nice to you? Yeah, okay. This is right? R cos r over 2, is that it? I think it should look something like that, right? Yeah, this one is better. You could have done it, so it's an excellent question. Why did we not do it with theta first? So with theta, you might have done it with theta, solve for theta in terms of r. Okay? Yes, sir?
Or are you like integrating one?
I'm looking for the area. What is the area? Let's call this region R, say. Area of R. Is the integral of 1 dA, right? Yeah? So, my dA becomes r dr d theta. Do you want me to integrate this, or that's fine? You know how to do it? Do you know how to do this or not? Should I integrate it? Do you want me to integrate it? Okay. Let's try to integrate it. So let's see. Oh man, it's gonna be bad. It's gonna be bad. So let's see. R squared over 2, this is 4. Oh, it's not that bad. 4 cos squared over 2. So it's 2 cos squared theta minus 1/2 d theta. Okay? Can you integrate it after? So what do you do? Cos squared is 1 plus cosine 2. This is 1 plus cosine 2 theta. It's not bad. 1 plus cosine 2 theta minus 1/2. So it's 1/2 plus cosine 2 theta d theta. Okay? May just as well finish it. So this is pi over 3, right? Integrate the first one is pi over 3. Plus sine 2 theta over 2. So what do you get? Sine 2 pi over 3. So you get 2 sine 2 pi over So you get sine, oh my god, let's see. Sine 2 theta over 2 from minus pi over 3 to pi over 3. So you get 2 sine pi over 2 pi over 3 over 2. So you get sine pi over 3. Sine 2 pi over 3. I think that's it, right? Sine 2 pi over 3 is root 3 over 2. Let's see if this has a... Yeah, no, I think it's good, right? You guys did it? You guys did this? Yeah? Yes, sir.
Is that only true for polar coordinates, the area of R, 1dA, 1
Everywhere, every region, right? We saw this, no? When you take a region, you double integrate it, dA. So the function you're integrating is 1.
Oh.
When you switch to polar, your dA changes, not your
Isn't
function.
that a thing you showed us, like how we moved one integral, this minus the same as double integral of 1?
Oh yes, yes, but this is in 2D now, right? This is the volume of a cylinder of this height, right? You remember? So we take this region and we just lift it 1, okay?
If you do the double integral of like a function, and
Yeah.
it's a new volume.
Well, it depends if it's positive or not, right? If the function is positive, then it's the volume under the graph z equal fx1, right? This is the main motivation of integrals.
Could you do this with one integral?
Pardon me?
Could you do this with one integral?
This one with one integral, let's see. So I need x and I need y, okay? X I think may be easy to describe here, because it goes from, it goes from here to here, right?
Yeah.
But what about the y values? Here to here, here to here, here to here, here to here, right?
Yeah.
So that's, and here to here, and then here to here. So it's not gonna be easy.
Okay.
Okay, you have to split it.
I was thinking like
Solving, rotate. Sure, you could do that. So if you rotate everything, this stays fixed. X squared plus y squared is equal to 1. And then the other one happens x squared plus y minus 1 squared is equal to 1. I think it doesn't change much. Okay, I think, right? Because the angles will just change, right? Instead of having r equal to 2 cos theta, you'll have r is equal to 2 sin theta. Okay, and the theta will change. I think it will be 5 over 6 and 5 over 6 maybe. Yeah. Okay. Yes.
When we're calculating the area of R equal to the double integral of 1dA,
Yeah.
for circles or for rectangles?
For everything, right? For rectangles, we saw this, right? So what's the area of a rectangle? Dx, do you want to say? This is b minus a and d minus c. Right? Okay. Great. Any questions on this? Any questions? Should we do one more like that? We do one more like this? Yeah. These are interesting questions. You should be very comfortable on how to do them. Okay, this one may be easier actually. Okay. The other one is easy, so I'll not do it. Now let's move on to discuss improper integrals. In calculus 2, you have discussed improper integrals, right? In how many dimensions? In 1, right? Now we're going to discuss improper integrals and multivariate improper integrals. The bad news is that these are complicated. These are not easy. The good news is that you don't have to worry a lot. The things you're in charge of are always the easiest possible cases. You just have to carry out an integration. If it works, it works. If it doesn't work, it doesn't work. Okay? That's what you have to do. Okay? So the theory is always, so in calculus 2 you allow yourself to talk about integrals of functions that switch sign, right? The functions may not have a constant sign. Do you agree? When you consider improper integrals. Here, we will assume that the functions have a constant sign. So they're always positive or they're always negative. This facilitates the theory a lot. Now, the theory is not easy to do, and you're not in charge of it. You're not in charge of the theory. I mean, I have it written here, but I think I'll just pass. I'll just give you the result, right? So, I mean, for you who are curious, maybe you can look at Fubini, Tonelli, and Fubini-Tonelli's theorem. These are not even in the book. I read them. So these are more, if you want me, I can write the results that you're looking at, that you're looking for. These are Fubini's. So a lot of theorems are Fubini's, Fubini, Tonelli, and Tonelli. Okay? There are many versions for these. You don't have to know these, you just have to know our Fubini. Okay? Fubini is more general than that, and it's more, anyway. Great! Now, improper integrals. So, if f is continuous, on AD times CD, we have seen that, let's call this R, we have seen that the double integral of R of fxy dA is equal, you integrate over y first, and then you integrate over x, which is also equal, you integrate over x first, and then you integrate over y, right? We said that all of these are equal if f is continuous, right? Everybody? Yeah. Now, if the domain is unbounded, or f is unbounded, things change. Things get more complicated. Luckily, if f is positive or negative, we can say things about this. Okay? So, if R is unbounded, it gets more complicated. If R or x, xy is unbounded, it gets more complicated. Now, we restrict our attention to the case where fxy is positive on R. Okay? The theorem, I wrote it in words, and I think I took this from the book. So, if fxy is positive or bigger or equal to 0, then the double integral dA must exist. So this means it converges to a finite value, right? Yeah? Or diverge to infinity. In this case, theory gets more complicated with more complicated conditions. Much more complicated conditions. But we will not care about this. If you think of switching to math, this is honors analysis 3 or 4. So like it's well, in the second years of math honors program that you see theorems like this. You see it for more general things. I could talk like 2 hours about this. It's very nice. Okay, in this case, convergence or divergence of fxy dA can be determined by evaluating the integral by iteration. Okay, iteration is just like you integrate with respect to y first or with respect to x first, and then you integrate with respect to y. Okay? Then you can choose the order you want. It will give you the same result. Okay? Same holds. Similar result. Holds if fxy less or equal to 0 on y. Anyways, enough written and enough said. Let's try to find an example. Lots of examples. Let's see. Great. Let us do an example. It's easy. Forget about this. Just stick to this. Evaluate R e of minus x squared dA, where R is the region. Let's see. It's a nice example. This one is a nice example. Okay, so R is the region of pairs xy, so that x is positive, and y lies between minus x and x. How do I sketch this region? Y is equal to x here, and y is equal to minus x here, and I'm looking at this region. Okay? Is it clear? Is it clear? Is this domain bounded or unbounded? X is positive, goes away. Is it bounded or unbounded? Unbounded. So I have, how do I set up this integral? X goes from where to where? 0 to infinity. And y goes from where to where? Minus x to x, right? E of minus x squared dy dx. It's going to be very nice, very nice. How do I integrate this? Everybody, are you following? This is my region R. Great. I integrate with respect to y. E to the minus x squared is what can I say about this? Is constant, right? So I integrate minus x to x dy, so I get 2x, right? I get integral from 0 to infinity. 2x dx, right? So far so good? Everybody, so far so good? Yeah? How do I integrate this one? This is just e to the minus x squared over 2 over minus 2, over minus 1 plus infinity to 0. E to the minus infinity, what is that? This is 0. And here is 1. E to the 0 is 1. The answer is 1. Right? You see that? Everybody, do we see that? Should we do one more? Let's try and do one more. First, is my function positive, by the way? Is my function positive? Okay, that's the most important thing, that the function is positive. Let's do one more. Okay, I have some examples here. Integral of 1 over x plus y squared dA over R. What is my region R? R is x between 0 and 1, and y between 0 and x squared. Okay, what do we do here? What's the first thing that we do? Very good, let's catch this. Wait. Actually, it doesn't make sense. Oh no, it does make sense, right? Where is my discontinuity here? 0, 0, right? So this is my region. This is my region I'm integrating, and where is my region bounded? It is bounded, right? But is my function bounded, or it could go crazy near 0, right? If x, y is 0, 0, is this function defined? Plug in 1 over 0 plus 0 squared, right? Doesn't work. You see that? Great. Now, so is this integral a proper integral or not? That's an improper integral. But, so we can, and is the integrand positive? Is my function positive? Great, so I can evaluate the integral iteratively. X goes from where to where? 0 to 1. Y goes from where to where? 0 to x squared. 1 over x plus y squared dy dx. Great, now how do I integrate this? What's an antiderivative of 1 over y plus x squared? It's minus 1 over y plus x, right? You agree? Here it's y plus x squared. We agree or not? We agree? Everybody, we agree or not? Yeah? And to differentiate this with respect to y, minus u prime, so minus 1 over y plus x squared dx. So what do you get? You get integral from 0 to 1 minus 1 over x squared plus x plus 1 over x dx. What about this now? Does it converge or does it diverge? Is this integral proper? No. Now how do I evaluate this? Partial fractions. Or you can put everything on the same denominator, whichever you want, whatever you want. Multiply both here by x plus 1, right? Dx. What do you get then? You get x over x squared plus x, right? Right? Everybody, do you agree? What can you do with the x's now? You cancel them. Is this proper or not? Do I have a problem? 1 over x plus 1, 0, 1. Do I have a problem with it? No. So I can evaluate that. What's an antiderivative for this? It's long absolute value of x plus 1, meaning it's positive anyway. From 1 to 0, just 1. Easy work. My function is, what's the most important thing? That the function I'm integrating is positive. Otherwise, everything breaks down. Okay, you can do it if the function is negative. The most important thing is that the function does not change sign. Otherwise, everything breaks down. Okay? Should you do a few more like this? Let's see. Are we, yes sir?
In the example, do we assume it's positive, or do we have to show it?
If it's obvious, it's obvious. Okay, this is obviously positive. Okay? Yeah, because there's a square, is that what you're, yeah? If it's obvious, it's obvious. Okay? But I can ask you show that this function is positive, and then, okay? Good thing when a multiple choice, you won't have to do it. If you have questions like a multiple choice, you won't have to show it's positive. Okay? And I won't trick you. So, if there is a question on multiple choice, the integral will converge. Okay, if you have an improper integral and multiple choice, the integral will converge. I will not give you a possibility it diverges. Okay, so it's going to be very clear. Okay, let's do one where it diverges, maybe. Are we good here, guys? Is it clear? Is this stuff clear? Let's try this. Integral r 1 over xy dA, where r is the region between x squared and x for y, and x between 0 and 1. Let's sketch r. So y is equal to x squared, y is equal to x. This is my region. Great. Is this integral proper? Is the domain bounded? The domain is bounded, right? But is my function bounded? Where do I have a problem? 1 over xy. Where do I have a problem? 0, 0, right? I mean, on the axis you have problem, but in particular, and 0, 0, which is the point that lies in my domain of integration. Great. Is my integrand positive on this region? Is xy positive on this region? So for xy in R, xy is positive. Xy is strictly positive. Well, it's 0, 0 xy, okay? Okay? Great, so 1 over xy is strictly positive. Great. What happens here? Let's integrate. X goes from where to where? 0 to 1, and y goes from x squared to x. 1 over xy dy dx. What's an integral here? What's an antiderivative of 1 over y? Ln of absolute value of y, right? So it's 1 over x integrate 1 over xy. It's 1 over x ln of absolute value of y. But y is positive. Do you agree that y is positive here? So I can just remove my absolute value. Do you agree with this, or do you want me to keep it? Y is positive here. Great, so what do you get? You get 1 over x ln x squared. So you integrate from 0 to 1. 1 over x ln x squared. What is ln x squared? 2 ln x, right? Minus ln x. You agree or not? Let's write it down. Ln x squared minus ln x. Because x is positive, right? The x's are positive. Yes, sir.
Isn't it supposed to be the other way around, x squared then?
Yeah, thank you. Thanks. Thank you. So here, minus ln x squared plus ln x. So you get minus ln x over x. What is this? Is this proper? Ln x over x from 0 to 1? No. And it diverges. You can see that it diverges. Can you see that? Can you see that it diverges? What's an antiderivative of ln x over x? Ln x squared over 2, right? Ln x squared, you see that or not? Ln x squared at 1, u prime, so u prime is 1 over x times u, okay? This is just, let me write it here, sorry about this, minus ln x squared over 2, from 1 to 0 plus, you can write of course 0 plus. What is this? This is just plus infinity. Okay? You see that or not? And then an antiderivative for ln x over x is what? It's ln x squared over 2. Do we see this? Yes or no? Yeah? Okay? How you do u sub? U sub, u equal ln x, right? We can do that the way you want. Let's do one more, and then continue with polar coordinates and improper integrals. Is it clear? Everybody, is it clear? Yeah? Yes? Yes. Or negative. If it switches sign, this doesn't work. You won't have to know. Okay? You just have to know if it's strictly positive or strictly negative. Okay? This is easy, right? Is it easy or not? Let's do one more. What is it? Where's minus?
Nothing, he's just asking if you can hear. Nothing.
Okay.
I answered this question.
Okay, great.
Small thing.
So let's see, ln 1. So minus infinity, is that the... We good here? Yeah? Yes?
It's only matters if it's strictly positive or negative in the negative, right?
Yeah, exactly. The outside doesn't matter. For example, here xy is crazy. Well, not crazy, but
Yeah.
changes sign. But it matters here. Okay? Great. Let's do one more. Add more.
Will we have a case where the sign changes and you have to like flip them somehow?
It's totally different. With the sign, this may break down. I mean, there are cases where one way you integrate, it works. One way you don't integrate, it doesn't work. Yes, sir.
Is that negative 1 x squared? Is that right?
Here?
0 to 1 over x. Is that negative 1 x squared?
Pardon me?
Like right to left and the bottom?
Here? Here?
Yeah.
Minus.
That's minus.
Yeah. So it's minus 2 ln x plus ln x, which is minus ln x. Okay, great. Let's do one more. Where r is the set x bigger or equal to 2 pi and 0 less or equal to y less or equal than 1 over x. Okay, x is bigger or equal than 2 over pi, sorry, and y is less or equal than 1 over x. Great. How do I integrate this? So first of all, 1 over, what do I need to check? Here it's not obvious. Here, for example, you have to tell me if it's good, right? If it's positive or negative. What do I do first? I sketch. X is bigger or equal than 2 over 5, and y is between 0 and 1 over x. This is y is equal to 1 over x, right? This is my region. Is it bounded? Is my region bounded? Is my region bounded? Everybody, is my region bounded? No. Great. Now, how do I check that my function is positive? Is x positive in this region? X is bigger than 2 over 5, so is x positive? So x is bigger or equal than 2 over 5, so 1 over x is strictly positive. Do you agree with this? If x is bigger or equal than 2 over 5, then 1 over x is smaller than what? Smaller than what? 5 over 2, right? This means that 1 over x lies in the first quadrant. Do you agree? So if I have a number in the first quadrant, its sign is positive, right? So sign 1 over x. Of course here because it's not 0, hence positive if x, y is an r. Here it doesn't depend on y. Okay, great. Now that this function is positive, I can evaluate the integral by iterating. So let's integrate. Y goes from where to where? X goes from 2 over 5 to infinity, right? And y goes from 0 to 1 over x. 1 over x sine 1 over x dy dx. Great. Now, dy, 0 to 1 over x. 1 over x sine over x when I integrate with respect to y is treated as constant. So what do I have to multiply? I multiply everything by 1 over x. So I get it's 2 over 5 plus infinity. 1 over x, right? Times 1 over x sine 1 over x. 1 over x squared sine 1 over x dx. What's an antiderivative for sine 1 over x, 1 over x times 1 over x squared? It's minus cos 1 over x. It's cos 1 over x, right? It's cos 1 over x from infinity 2 over 5. This is cos 0 minus cos pi over 2, which is 1, right? Okay? Are we good here? Are we good? Yeah? Any questions?
What does that do to get the
What's last time? Here?
Oh yeah,
From here to here?
no, from 1 over x squared to 1 over
Here?
yeah.
Put u equal 1 over x.
Yeah.
Okay? And integrate.
Ah.
Okay? The other way to say that this is the antiderivative of 1 over x squared, something like it, times the antiderivative of cos of 1 over x. So it's 1 over x prime times cos prime 1 over x. You have minuses, of course, I have to worry about the sign, and then you worry about the signs when you do this. Okay? Just do it yourself. You do u equal 1 over x, and it will be clear. Is it clear? Yeah? Or differentiate this thing. What's the derivative of cos 1 over x? The derivative of 1 over x, which is minus 1 over x squared. The derivative of cos is minus sine. So it's minus 1 over x squared times minus sine of 1 over x. Minus minus plus. You get this. Okay? Yes, sir?
How did you change that to 5 over 2?
1 over x, if x is equal to 2 over 5. Okay? Great. You should be comfortable with calc 2 stuff here. Yes, sir? Okay? You should be comfortable with calc 2 stuff. You've done this in calc 2, right? One integral. Okay, this is what it comes down to. Okay, great. Now, let us try to do things in polar coordinates. Is this clear? Is this stuff clear? Is it clear? Great. Let's do stuff in polar coordinates and proper integrals in polar coordinates. And I ask you to integrate over r ln of x squared plus y squared dA. What is r? R is just the disk, or the disk of radius less or equal to 1 centered at the origin, except the origin itself. So r is just puncture disk, right? The disk without the center. Okay, great. Now, ln x squared plus y squared, is it positive here, or is it negative or positive, or does it change sign? Does it change sign or not? It's ln of something that is less than 1, so this ln must be negative. Does it change sign? No, right? Because the inside is strictly less than 1. Do you agree or not? So this theorem holds. Okay, now let's switch to polar. What happens when I switch to polar? How do I switch this to polar? What happens to x squared plus y squared? R squared, yeah, but what happens to this integral? So this, sure, ln of r squared, very good. Ln of r squared, what is dA in terms of angles? R, dr, d theta. Now, r goes from where to where? 0 to 1. Of course, this is an improper integral, right? Because you have a ln. Great. And then theta goes from where to where? 0 to 1. 0 to 5, right? Great. Let's integrate this thing. This is 2 pi integral of 0 to 1 r ln r squared dr. You can do that in many ways, right? You can bring the 2 inside and then use a u sub, or you can integrate by parts, whichever you prefer. I prefer a u sub, right? You see that? If you're going to integrate by parts, don't integrate by parts, just do a u sub. What's the antiderivative of ln x? It's x ln x minus x, right? So put the 2 here. Okay? This is an antiderivative of pi, so it's ln x squared ln x squared, r squared ln r squared minus r squared. From 1 to 0. Yes, sir.
How did you go from that to that? Did you integrate with respect to d theta or d?
Exactly. It's a product of 2 functions, right? Do you agree? Does it depend on theta? It's a rectangle in r and theta, you agree? In r and theta, this is a rectangle. So you can integrate them, you can split them. Okay? Is that clear? R squared ln r squared, so it's minus pi here. Right? You see that or not? You see this integral? You see that? Differentiate this, you get this. So it's 2r ln r squared, this is the term I want, okay? Yep. Plus r squared, what's the derivative of ln r squared? It's 2r over r squared, right? Plus 2r, and then minus 2r. That's the term you get, okay? And what's the limit as u goes to 0 of u ln u? This is 0, right? You know this from calculus 1. Okay? You see this in calculus 1, right? Or if you haven't seen it, just look me down it. bring the 1 over u, log u over 1 over u, infinity over infinity, use L'Hopital, you'll get it. Okay? Great. Now let's do one more. Well, actually, let's do something more interesting. Important integrals. Now we'll use the methods we developed to find an integral like that. First of all, this integral exists. You agree this is a finite number, or can you convince yourself it's a finite number? If not, try just to bound it. Basically, from 1 to infinity, e to the minus x squared is smaller or equal than 1 over x squared. And 1 over x squared you can integrate it from 1 to infinity. So really, this integral exists. You can show that this integral exists. Okay, it's a finite number. You've seen this in Calc 2, sorry. You see that you bound this by 1 over x squared on 1 to infinity, and this integral exists. On 0 to 1, obviously it exists. So 0 to 1, 1 to infinity exists. And it's an even function. Okay, so this integral exists. How do I find the value? The idea is to use double integrals. Double integrals will allow you to Okay, the idea is to use double integrals here. And to use the Fubini theorem on an infinite rectangle. Great. Okay. We agree that this is equal to I. So far so good. Now if I square I, do you agree with this? This is equal to I, and this is equal to I. Y is a dummy variable here. X is a dummy variable. You agree or not? Everybody, do you agree? If you replace x by t and y by z, this is still true. Right? Now let's merge them both together and see what we get. Which one comes first? dy dx. Yep. You'll see what. Just do this. I split them into a function, a product of two functions. You can put t, you can put z, you can put a, you can put u, right? You agree? Now, do you agree with this? It's a product of two functions over two infinite rectangles. These functions are positive, so I can apply the previous result. Do you agree with this? Does everybody agree with this? We agree with this? Everybody. We usually go from here to here, but now we're going from here to here. Everybody. So far so good. Yes, sir.
How did you change it to variables?
You agree that I squared is this integral times this integral, right? So, this is a function of two variables that are independent. And both of these integrals exist. It's a product of two functions over an infinite rectangle. You can split them into the product. Okay? Great. Now, what do I use here? What can I integrate this? I mean, first of all, what is my region of integration in the xy plane? What does it look like? X goes from minus infinity to infinity, and y goes from minus infinity to infinity. What does this look like? The whole plane, right? My region of integration is the whole plane. Okay. And what do I have in the integrand? I have e minus x squared minus y squared. Is this easy to integrate? Can you integrate this nicely? No, can you? Now, x squared minus y squared. Minus x squared minus y squared. Let me just do it. What change can I do here? I can switch to polar. Let's switch to polar. Let's switch to polar. I'll leave this here. What happens to x squared plus y squared becomes r squared. dx dy, what happens to dx dy? R dr d theta. Okay? R dr d theta. This is the r. Let's do the r. Okay. Now, theta, where does it range? If you're in the whole plane, theta, from where to where? 0 to 2 pi. And r, if you're in the whole plane, 0 to infinity. Okay, this is very good, thank you. Oh, wait a minute. Can I integrate this nicely? So, I take the 2 pi out. This function is positive, sure. 2 pi. And r e to the minus r squared. E to the minus r squared over minus 2 from infinity to 0. E to the minus infinity is 0, right? Plus the plus 1/2, right? Minus 1/2. So you get pi. You see that? We see this? This is cos 2, right? So I squared is equal to pi. And I is positive, because I'm integrating a positive function. So I is 2 pi. So the integral. You have to know this, okay? Is it clear here? Are we clear? Is it clear? Yes, sir.
Why do we have to know this specifically?
Pardon me?
Why do we have to know this specifically to support functions? So you want to
Yeah, I mean, if you know, have you seen the normal distribution? This is similar to the normal distribution, right? Have you seen the normal PDF? You haven't taken any probability. Have you taken any probability course? So if you take 1 over root 2 pi e to the minus x squared over 2, right? You need to show that this integrates to 1. And really this is here. This comes from here. Okay? So you have to know this result, you have to know the proof and the result itself. Okay? Again, what do you have to know? The result and the proof. The result and the proof. Okay? Great. What time is it?
1 hour.
1 hour. We have 1 hour left? Okay. Great. Is this clear? Is this thing clear? Any questions on this? No? No questions? Is it clear? Great. You know, we're going to do more exercises now, and then we'll move on to triple integrals. Okay. Great. Now I think it's a good way to start this section. We're going to start cylindrical coordinates, but first we'll start doing by more volume exercises. First of all, last time I gave you an example. Remember, I think this is the number I had, 9 minus x squared. And I told you to find the area of this, between the x-axis and this curve. I have to solve for the points of intersection, right? And integrate where this region is, where this function is, positive, right? You remember this? And then we solve the analog for this in 3D. If I need to find the volume under a surface above the xy plane, I have to find the intersection of this surface with the xy plane, and the intersection is most likely, or it's going to be if you don't have the bounds, if it intersects it, it's going to be a line, a curve, right? The intersection is going to be a curve, and I'm going to be integrating over a region. You remember this or not? Should I give an example, or that's fine? That's fine, right? We did this last time. Now, you remember this from last time or not? Yes? Okay. Now here I have to. What if I ask you to find the volume of the region? Bounded. Let's get something nice. Or above. Above the cone, z is equal to square root of x squared plus y squared, and below the sphere so I'm giving you, first of all, let's draw something. I think we used that cone before, right? We've used this before. The tangent plane to such a cone passes through the origin, right? Remember this exercise? We did this with a cone like that. And I have a cone, okay? I have to do my draw better. Let's see. You have a cone like this. And you have a sphere. I'll create this one. And I'm asking you to find the volume of the region between the cone and the sphere. Above the cone and the sphere. Oh, how do I draw the region? It's a good question. Draw z is equal to root x squared plus y squared. What is that? The distance, right? Take the distance. Go up. Okay, this is just the distance from the origin to. Okay, z is equal to root x squared plus y squared. This is just the distance from the origin to the point x y z, to the point x y z. Okay, you can convince yourself that this is easy to draw like that, and the sphere is easy to draw. I mean, it's not very easy to draw, but okay, this is a region like that. Now, how do you find the volume between the cone and this sphere? We could do an easier one if you want. Do you want to do an easier example? Let's try to do this one and then do an easier example. How do you draw this? Region. How do you find the volume of this region? Let's remember something in Calc 2. Here, do I give you a region in X, Y, or I just give you the shapes, right? Do I give you anything about X and Y and Z? Not really. Now let's remember a question in Calc 2 that you had. Let's say find the area between Y is equal to 9 minus X squared and Y is equal to X squared plus 1. Do I give you anything about the X's here? Did I give you anything about the X's, or I just gave you the two curves? The two curves. How did you tackle this question? The first thing, what did you do? You drew a rough sketch of the curves, right? And here it's easy to draw a sketch. Right? And then you identified the region you want to integrate over. What is the region? What is the region you want to find the area of? This one, right? So far, so good. Everybody, what did you do? What's the other thing that you did? Yeah, someone said this, yeah? Who said? You said? Oh, intersection points. How do you set the intersection points? You set them both equal to each other. So you have 9 minus X squared is equal to X squared plus 1. So it's 2X squared is equal to 8. So X squared is equal to 4. You get X is equal to plus or minus 2, right? Minus 2 and 2. And you integrate from minus 2 to 2. What is the upper function? 9 minus X squared. Yes. That's how we did it, right? Here we're going to do the same thing. We're going to intersect the two regions, right? And so when I intersect the two surfaces, what do I get? Here I get points. There, what will I get? A curve. And here I have to integrate over an interval. There I have to integrate over a region. Let's do this. So you agree that Z is positive. If Z is equal to square root of X squared plus Y squared, and X squared plus Y squared plus Z squared is equal to 1, what can I say about Z? Z is positive, right? Now if Z is positive, or you put it 0. If Z is positive, can I solve for Z in terms of X and Y? Can you solve for Z in terms of X and Y? Yeah? So here you can do it in many ways. I recommend that my recommendation is just to solve it in terms of R. So here it's easy, right? You have X squared plus Y squared is equal to R, right? And Z is equal to R. So Z is equal to R. And yeah, okay? So what do you have? You have Z is equal to R. And X squared plus Y squared, which is R squared. R squared, well, you know what, let's keep this. This is just Z squared, right? X squared plus Y squared is Z squared. Plus Z squared is equal to 1. You agree? X squared plus Y squared, what is that equal to? Z squared, right? Z plus Z squared is equal to 1. So what is Z squared here? Z squared is equal to 1/2. Do you agree or not? is the curve of intersection here? It's a circle, right? So this is equal to 1/4, right or no? It's a circle of radius 1/4. No, what am I saying? What am I saying? What am I saying? 1 over root 2, right? It's a circle of radius 1 over root 2. At the height, z is equal to 1 over root 2. You see that or not? Try to sketch this. Z is equal to root x squared plus y squared. So it's x squared plus y squared is equal to 1 over root 2. It's equal to 1/2. So it's a circle of radius 1 over root 2, right? At the height, z is equal to 1 over root 2. This is the circle. This is the intersection. You agree or not? Just you solve these two equations. This is what you get. Now, what is the region you're integrating over? You're integrating on the projection of the region inside in the xy plane. Right? You see that? You're taking this region up there and you're projecting it into the xy plane. This is where x and y will vary. Okay? So far so good? X and y will vary in this region. What is this? So x and y will vary. Which is less than 1/2. And z from where to where will it go? So let me do it here. Z is equal to r. R squared is less or equal than 1/2, right? From here you can identify what is the smallest, what is the biggest. But from the graph, what is the biggest? Is the sphere or the cone? Where is the higher? Sphere is the higher, right? Z goes from the cone to the sphere. You agree? So Z will go from square root of x squared plus y squared to square root of 1 You see that? You see that? Z is between r and 1 minus r squared, right? So z squared, solve for this. We agree that z is positive. We're looking at a positive z. Z will go from r, from z is equal to r, to square root of 1 minus r squared. Now, notice that r squared is less or equal than 1/2. Right? So I gotta have that r is less or equal than 1 minus r squared. Square root of 1 minus r squared. If r squared is less than 1/2. So if r squared is less than 1/2, then 1 minus r squared is bigger or equal than 1/2, which is bigger or equal than r squared. You see that? R squared is bigger than 1/2. 1 minus r squared is bigger than 1/2. Just put the minus as the 1. And 1/2 is bigger than r squared. So square root of 1 minus r squared is bigger than r. Square root both sides. Are we following? Is this okay or not? This is my x and y, right? If x squared plus y squared is less or equal to 1/2, then you agree that 1 minus r squared is bigger than 1/2 or no? You agree with this or no? Just put minus r squared is bigger or equal than minus 1/2, then add 1. You get 1 minus r squared bigger than 1/2. Right? So far so good. Yeah. Now you let it 1/2, it's bigger than r squared. Here, you bring it here. What is the bigger function? Z is equal to r, or Z is equal to square root 1 minus r squared? This one is the bigger function. So Z will vary. Remember here we have the difference of these two. And here you will have the difference of these two as well. Or you can do that here. Difference of these two is root. And what is the region you're integrating over? Upper surface, minus lower surface, region of integration. If it's not clear, we're going to do more examples. That's fine. Any questions on this? Ask. It's the time to ask. If you're confused, which I'm not surprised you are, you should ask. Pardon me? Yes, yeah. Yes, that's right. That's right. We agree with this or not? Here, what did you have? You had upper function minus lower function over the interval where this is the biggest, right or no? Here you have the same thing. Upper surface minus lower surface over the region where this is bigger. How do you find where this is bigger? You solve them equal to each other, you get a curve, right? And the curve has inside out, right? You see that? If a point in the inside satisfies this is bigger than that, then this is how you do it, right? Yes, sir.
So if you're unable to see which one is bigger, can you just guess and take absolute value?
Yeah, but I mean, if you take the absolute value, you still need to remove the absolute value, right?
So by the time you solve the integral and whatever value you get.
Oh, you take the absolute, yes, sure, yeah. But if I ask to find a volume, right? But sometimes if I ask to integrate a function, basically, it's okay. But yeah. So let's do this. Let's evaluate this integral. How do we evaluate this? What's the best way to evaluate this? Polar coordinates. Should I evaluate it or that's fine? Should I evaluate it? Should I do it? Is it clear? I mean, you know. How do we evaluate this? So r goes from where to where? 0 to 1 over root 2. Theta goes from 0 to 2pi. I have root 1 minus r squared minus r d theta dr here. Here it is 2pi. Oh man, it's gonna get a bit rough, but that's fine. 0, 1 over root 2. Right? That's what you get. That's easy to integrate, right? It's 1 over r squared to the 3 halves divided by 3 halves times 1 half minus that. Okay? This is easy to integrate. This is easy to integrate. I'll let you do that. Okay? Or you wanted to integrate this? You want to integrate it? This is calc 2, right? You know how to integrate this from calc 2. Okay, you get an answer. Okay, let's do one more. Find what? Find the volume. This one is easy. Bounded by Z is equal to 2x squared plus 2y squared. And Z is equal to 6 minus x squared minus y squared. Now these may be difficult to sketch, right? But I mean, these are just parabolas, but in 3D. Paraboloids, right? These are paraboloids, but in 3D. This one, what do you expect it to be? This one has a maximum, right? This parabola has a maximum, which is at 0, 0, right? Because this is always smaller than 6, right? You see that? And this is always bigger or equal to 0. You guys see this? This one is always bigger or equal to 0. This one is always bigger, smaller or equal to 6. So what's a good way to draw that? Means there it is. There it is. And there it is. Okay? You cannot draw it exactly, but this is how we draw it. Great. Now these two will intersect and a curve. How do I find the curve of intersection? What? How do I find the curve of intersection? I set them equal. You agree? How do I find where they intersect? You set them equal. What is the highest, by the way? What is the higher one? The 6 minus x squared minus y squared is bigger than 2x squared plus 2y squared, right? Set them equal. What do you get? So what do you get? You get 3x squared plus 3y squared is equal to 6, so you get 2, right? And what is, and z is equal to 4, right? So z will be equal to 4. If x squared plus y squared is equal to 2, and z is equal to what? 4, right? X squared plus y squared is 2, z is equal to 6 minus x squared minus y squared. 6 minus 2 is equal to 4, or 2 times x squared plus y squared, which is equal to 2 times 2, which is 4. So the curve of intersection is a circle of radius 0, 0, 2, of radius 2, at height z equal 2. Right? This is my intersection. Right? Now, when you project this into the xy plane, where will x and y vary? Just project into the xy plane. Where will x and y vary? So I have to integrate. What is the bigger function? This one is bigger, right? You see that? Minus dA. Where are you integrating here? Where do x and y vary? Where do x and y vary? What is the relation between x and y here? You're projecting this region from the plane z equal 4 to the xy plane. Are you looking inside of the disk or outside of the disk? Inside, right? So where do x and y vary? X squared plus y squared, these are equal. How do you evaluate this integral? Polar, right? You see that? Should I evaluate it? I mean, it's easy to do with polar. Great. What do you get from polar here? R goes from where to where? R goes from 0 to root 2. Theta goes from 0 to 2 pi. 6 minus 3r squared. R dr d theta. Okay? Yes, sir. X squared plus y squared less or equal to, right? Okay. Are we good here? In the back, are we good? Yeah? Okay. Are we good? Yeah? Is it clear? Can you evaluate this? This is, you can evaluate it versus just putting it. Should I, do you want me to evaluate it, or, it's fine? Great, let's do more. Let's do more. Let's do more. How much time do we have left? 30 minutes? 40 minutes, okay. Great. Find the volume. Of a sphere of radius A. A is positive, of course. Great. How do you do this? What's the sphere of radius A? What's an equation of a ball? Of a ball here. Of a ball. Of radius A. Sphere is the surface. So what's the equation of a ball of radius A? How do I find this? Everybody, how do I find this? First thing, what do I do? I sketch. Let's sketch. Okay. I didn't sketch much. I just sketched a circle. I hope you can picture this is a sphere. If I had this here, I think I may be able to. This is a sphere. How do I find the volume? Can I say that z is ranging between two functions of x here? Between two functions of x and y? Can you see? Can you check whether z is ranging between two functions of x and y? Clearly, z is not a function of x and y, right? Because you have two branches. You have two ways to do this, right? You have z is equal square root of a squared minus x squared minus y squared, or z is equal minus square root of, and so on. But for a pair xy, z ranges from where to where? We do something easier. Let's look at the circle. For a number x, y ranges from where to where? Y ranges from here to here, right? Y ranges from minus root 1 minus x squared, y, and x is between minus 1 and 1. You agree? Everybody, do you agree? Yeah? We good? 100%. Here, what happens? If you have a pair xy in the xy plane, what can you say about its z so that you cover the entire ball? I have the ball here and a point xy in the xy plane. What can you say about the z value so that it's inside the ball? Z of that point where? Look at this example. Fix xy, okay? And I tell you, I want the values of z in terms of xy such that this point, the point xyz, is inside the sphere. You have the sphere here, right? Well, I mean, anyways. You have a sphere here, and you have the xy plane here. I have a point, I fix coordinates of a point, xy, I fix them. The z value of this point, should it be inside the ball? Between what two functions of x and y does z vary? Look at here, try to think about this. Look at the circle. You fix an x, right? You fix an x here. Between what two functions of x does y vary? This function here and this function here. in 3D, you fixed x and y. Between what two functions of x and y does z vary?
Square root 1 minus x squared minus y squared and minus square root 1 minus x squared minus y squared.
Is that what I'm saying?
Yeah.
Okay.
I was gonna say a squared.
A squared minus x squared, yes. Yeah, a squared, right, thank you. You agree? This sphere this set you agree? I have a missing condition. What is my missing condition here? Look at here. Y varies from these two things, and x is between -1 and 1, so that this square root makes sense. Here, what should it be? In terms of x and y. X and y should be in what region? What should they satisfy? X squared plus y squared is less or equal than a squared. We see that or not? You agree that this set is this set? Yes? Okay. First of all, you agree if a point to belong inside the sphere, then x squared plus y squared should be less than a. Right? Because you have x squared plus y squared plus z squared is less or equal to a squared. So this is at most a squared. You agree? 100%? Because of this. Great. Now fix a point xy. Fix a point with, so fix the coordinate of a point xy. Fix them. Fix the first two coordinates. Z, are you free to let range Z wherever you want? Or it should be bounded? It should be bounded, right? It goes like this, right? Say this is the center of the sphere. So, between what two functions of Z? Try to solve this. So you have Z squared is less or equal than a squared minus x squared minus y squared. We agree with this, everybody? Great. Try to solve this. Absolute value of Z, or let's not do that. X squared plus y squared is less or equal than a squared, so this is a positive number. If a squared is less or equal than b squared, then a is between minus b and d, right? If b is positive, so minus. You agree with this? Is this more convincing? From here to here is clear, right? Is this more convincing than the picture? If you're happy with this, then this is better actually. Okay? Is this clear or not? This is the line saying y is equal to x squared. And if y is less or equal than a squared, this means that minus a, right? A is positive. Right? Z squared is less or equal than this. So that's Z is between the square root of this and minus the square root of this. Is that clear? And then you evaluate the integral. How do you evaluate the integral? How do you evaluate the integral? X and y range in what region? X squared plus y squared is less or equal than a squared. Upper function, what's the upper function of Z? Square root. And minus square root. Dx dy. Great. So I have 2 square root a squared minus x squared over a disk. What's a good thing to use here? Everybody, what do we use? Polar. What happens? R goes from where to where? A is positive. R goes from where to where? 0 to A. And theta goes from 0 to 5. Great. What happens here? Root a squared minus x squared. Root a squared minus a squared, right? Minus that, so it's 2. Dx dy, what happens to it? R dr d theta, thank you. R dr d theta. Let's integrate that, so I have 2 pi here. 2 pi, 2r square root a squared minus r squared. How do I integrate that? This is a squared minus r squared. So it's 3 halves, right? Over 3 halves times minus 1, right? From a to 0, if a is 0, so at 0 it's 2 pi, so 2 times 2 over 3, so it's 4 pi over 3. If a is equal to 0 minus, so you get a squared is 3 halves, you get a cubed. Okay? I just evaluated the integral. Okay? 4 pi over 3 a cubed, is that the function you learned or not? Is that the volume formula you learned? You didn't learn this? If you didn't learn this, now you can learn this. Okay? So you have to know that the volume of the sphere is 4 of radius a is 4 pi over 3 a cubed. Okay? Are we good here? Is it clear? Let's do more examples. Questions? Are we good? Do you have questions? No? Let's see if we could should we do more? Should we do more? Where's 5? Is it actually 5? We do more examples? Let's do more examples. Let me actually try to find more examples in the book. Because if I do my own examples, I think they go a bit okay, you know what? Let's do one more. And then or you know what? I'll do something else. I'll do something else. Okay? Is this clear? I'll start something else and do another coordinate system. So what do you prefer? We move to 3D now and then do something hard in 2D, or we stay in 2D and you move to 3D tomorrow? We move to 3D tomorrow? What do you guys prefer? We move to 3D tomorrow. Okay, so now we'll give, okay, so now this is the harder part in 2D integrals. So what's good about this part is that we will review the volume in 3D integrals. So if you feel it's not enough practice, we're going to do more practice on this. Okay? Just when we do the volume in 3D. Okay. Change of variables. And dimension. Now we have seen a particular change of variables in 2 dimensions. What is it? Remember what is it? The polar coordinates, right? Okay. Polar coordinates. I took x is equal to r cos theta, y is equal to r sin theta. So I use the Jacobian del xy. I used r theta, right? I used r theta or theta r. I think I used r theta, right? R theta here. In absolute value is equal to r, right? Remember this? And we saw that dx dy, or dr d theta, or whatever that is, so What is the formula? dx dy is just the Jacobian in absolute value. Should be non-zero, of course. dr d theta. Right? You remember this? You remember this or not? Now, in general, we'll just try to do more functions here, not necessarily r equals theta and r sine theta. So, if x is equal to x cubed b and y is equal to y cubed b, dx dy, what is that equal to? And here, of course, we're going to assume that del xy okay? I mean, it's a change of variables that is not necessarily, a nice change of variables, but so let's give a small example. Maybe very brief. Of the region bounded by and x is equal to 3 y squared. So I'm in 2D, let's draw these pictures. This is y is equal to x squared. This is y is equal to 2x squared. And then what do I have? I have x is equal to y squared. Right? I don't know if they, well, they don't even draw it. Okay. And then I'm even lost here. Yeah, x is equal to 0. So you're really looking for this area. So for this section, unless the change of variable is very obvious, I will be giving you the change of variable. Okay? So if you have to do such a question, I will tell you what change of variable to do. Because this is not an obvious change of variable. It is, but it's not an obvious one. Okay? I think you can spot it from here. Use u is equal y or x squared over y, and b is equal to y squared over x. So let's write it this way: y over x squared. This is y over x squared is 1. X squared over y is 1/2. Wait. squared over y is equal to 1. X squared over y is equal to 1/2. Y squared over x is equal to 1. And y squared over x is equal to 1/3. You see where this is going? If I set u is equal to x squared over y, u goes from what value to what value? From 1/2 to 1. And if I set v to be y squared over x, v goes from what value to what value? 1/3 to 1. Okay, that makes this complicated region in xy, makes it look like what in uv? Like a rectangle. You see that or not? It makes it look like a rectangle. Now, provided it's easy to integrate over a rectangle, isn't it? And I have to find my Jacobian. Great. This thing tells me that I need to find del xy over del uv. But here I do have that uv in terms of x and y. Yes, sir.
How does like x go over y equal to 1?
How is that x here? Under. Y is equal to x squared. What is this curve? This curve is x squared over y is equal to 1. This curve, x squared over y is equal to 1 over 2. Okay? So really, u is varying from 1/2 to 1, and v is varying from 1/3 to 1. You agree? So I turn this region between 4 parabolas into a rectangle, which is very nice. Now what do I need to find? I need to find del xy, del uv. You agree or not? Let's call this area R. R, the area of R is 1 dA. Well, I mean, I'll use this one, which is dx dy, which is the integral from u and v. V goes from 1/3 to 1, and u goes from 1/2 to 1, dv du. Now here, what do I have? What do I have to integrate here? The Jacobian. Great. But wait a minute. I have u and v in terms of x and y. Do I have x and y in terms of u and v? You can find del u del x. You agree with this? And you can find del u del y. You can find del v del x, and you can find del v del y. Do you agree with this or not? Is it easy to find del x del u, or it's a bit hard? You have to solve and eliminate. You agree? You have to solve for x and you have to solve for y. You can do that. I think you may be able to do that. You may be able to do that, actually. So what's u over v? No, maybe not. Who knows? Anyways, if I find the Jacobian of del u v over del xy, can I recover del xy over del u v? Yes. By what? It's 1 over. Remember that the Jacobian of del x u v of del xy del u v, this matrix, should it be invertible? It's the inverse of del u v over del xy. Remember this, right? And we saw that in general, if you have a function of two variables, del x del s is not equal to 1 over del s, 1 over del x del s, right? You remember this? You remember this or not? We saw this as an example when we did the Jacobian. You remember this or not? Yeah? So into D, I should just find del u del v over del xy, and then invert the result and hope for the best. So what is del xy over del uv? Del x del u. What is del x del u? Sorry, what is it's del u? Del u v over del xy. What's del u del x? It's 2x over y, right? And what's del u del y? It's minus x squared over y squared. What's del v del x? Oh, that looks nice. Minus y squared over x squared. And what's del v del y? It's 2y over x. What is the determinant? It's it's 4xy over xy, so this is 4, right? Minus 1, right? 3. You agree or not? You agree? Take the product, take the determinant of this thing, what do you get? 3. Yes or no? You took determinants? You want me to write the whole thing, or that's fine? It's 4xy over xy, that's 4. Minus, when you take the product of these two minuses, they become plus. Y squared, x squared, y squared, minus 1. 3. Great. So what is del xy? Del uv. 1 over 3. I get back here. Absolute value of my determinant is 1 over 3. Times integral from 1/2 to 1, 1/3 to 1. 1, I took out the 1/3 already. What do you get? You get 2/3 times 1/2. Oh, 1 over 9, right? Very nice. Very nice. Yes, sir.
I don't really see what you did over there. I see what you converted it.
Where?
Like, from Jacobian to the over the to the.
Here?
Yeah.
This becomes 1 over 3, right? Take it outside. You're integrating 1 over a rectangle. It gives you the area of the rectangle. 2/3 times 1/2. Okay? 2/3 times 1/2 times 1/3, you get 1 over 9. So should you have a change of variable like that? So because this is something, they may do it in 262 or they may not. But if you have a change of variable like that, I will give it to you. I'll tell you use this change of variable. Okay? Now, let's do one more with an obvious change of variable. Find the volume above the xy plane and below. Who wants to give me their favorite number? Favorite number? 7. What? Favorite number? 8. Okay, 7 squared, 8 squared, okay? Great. Now technically, we know how to do this question, don't we? How to do this question? I have a volume above the xy plane and under a surface. What happens here? What do I have to find? The intersection of the surface and the plane that is equal to 0. What do I get? I get a curve, right? And I have to integrate inside this curve, right? You see that? So what is this function? What is the intersection here? It's 49x squared plus 64y squared is equal to 1. You agree with this? So what I have to integrate over in the xy plane is this set. And I have to integrate it. Right? Do we agree with this or not? This is the volume, you agree? Everybody, do we agree? I mean, you need Z to be positive. Always think about it. You need Z to be positive in that case. If Z is positive, this means that 49x squared plus 64y squared, I missed a 4 here, is less or equal to 1. Okay, now, if I had x squared plus y squared instead of 49 and 64, what could I have used immediately? Polar, because my region would be x squared plus y squared is less or equal to 1, right? Now, can I still use polar? I can use polar, but I have to first a transformation. So if you let u is equal to 7x, and v equals to 8y, what happens here? U squared plus v squared is less or equal to 1, right? So, if I transform this, if I do this transformation, I can use my polar coordinates. Do you see that? This becomes integral of what? Of u squared. That's equal to 1. U is 7xv, and then it's 1 minus v squared. What is the x dy? Yes? The Jacobian, very good, thank you. What is the Jacobian in this case? So what is del xy? I mean, you can compute it here very easy, right? You can take x is u over 7, and y is v over 8. What is the Jacobian? Del x, del u is 1 over 7. Del y, del v is 1 over 8. This is 0 is 0. It's 1 over 56. Really, it's 1 over 56. I mean, it's a constant, so it doesn't. The Jacobian may depend on u and v. Just, we were lucky it did so far. Okay? Now, how can I do this? How can I evaluate this integral? What's the region of integration in u and v? It's a. In u and v, the region is a. This. So what can I use? Polar coordinates. Are we good here or not? Yes or no? So it's integral from 0 to 2 pi, 0 to 1, 1 minus r squared, r d theta. Is it clear, folks? Are we good? Let's switch to polar again. How much time do we have left? 2 minutes. Okay. I had something written. Just it's more like, and then do this. Okay. It's more like. Where is that? Tips for the final. Good. And maybe I should. No, that's fine. We can keep it so that if someone wants to rewatch it. Okay. Great. So where is that? Yeah. Okay. So what I want you to look for the final. I mean, it's 1 week. It's in 1 week. You should know very well Lagrange multipliers. you should know like finding maximum and minimum and classify the critical points of a function. You should know that very well. Extremum over bounded domains, closed and bounded domains. Extremum over closed and bounded domains. So like you look at the boundary. Okay. Double and triple integrals. Those will be a very important part of the exam. Integrals, double and triple. We'll see triple tomorrow. Those will be a substantial part of the exam. Improper integrals, they'll also be a big part of the exam. Well, not big, I don't know how big. Big is that you may have a question on it. Okay, this is big. Okay, but I'm saying this is the new stuff. So, series, you have to know series. And you have to know the expansions. You know, ln 1 minus x, e to the x, cos x, sin x. If you don't know them, what do? You redirect them. That's fine. Absolute convergence, you should know this, absolute, conditional, things like that. Of course, what's an important thing? Chain rule is very important. Chain rule. You will get a question on chain rule. So questions on chain rule involve like differentiating 5 times, for example, well, not 5 times, 2 or 3 times. Tangent plane approximations, things like that.
You need to know how to approximate.
Pardon me?
You need to know how to do the approximation.
Yeah, it could be a question. Yeah. Proofs, you need to know to do all the proofs that we have done in class. So for example, this result, e to the minus x squared is impossible. I can ask to redo the proof. If you remember in directional derivatives, we've had some proofs as well. And we've seen some exercises, you know, like some proofs where we don't plug in numbers basically. In this course, that's what we call a proof. You can do that. So where you don't plug in numbers, I'll call this a proof. You will have an exercise like that in the long answer. Yes, sir.
How many proofs would be following?
Yeah, I think I put only one proof. And could be something from what's coming, you know, from the new chapter we'll do. Okay? So it may be on curves, when we do curves. I may give you a proof on curves. They're not very difficult. I may give you something very easy actually, but who knows. And curves, you will have a question on curves. Okay, like the next chapter. It will not be a very hard question. Okay, so it could be a proof that we have seen, for example. And most importantly, the implicit function theorem you have to know. Okay? Yes, sir.
Is there any way to give us the work that has like things and everything?
Yeah, sure. I was gonna do that. I will give you a web work of like 60, 70 questions due on like monthly. Okay? Pardon me? The implicit function theorem or change of variables? Yeah, sure. Okay, yes, sir. The what word? Sure.
So we know what to expect.
Yeah, definitely. It will be of the same difficulty. I'll put questions of the same difficulty, yeah. So as I said, folks, change a variable like this, where u is 7x and b is 8y, I expect you to know how to do that. Change of variable like the previous example, I will give you the change of variable. I'll tell you, use this change of variable to find, okay?